So now let's do the scale. I think that's the only thing that's left. The scale we're gonna do with GLSL. And let's insert, because that's just, I think, too complex to do with that. Let's just add a GLSL. It's quite straightforward, don't be afraid. We're gonna walk through this. The first thing I want to do is, how do we represent a scale? Let me stop this MIDI and there I am. So at the moment what we're doing is, let's say that's 60. That's what, those are the notes that we're using. Oh wait, this is, let me mirror the camera because this is very confusing. So let's take flip, make that a parameter. In fact, let's also do this while we're at it. Okay, so we've added those there, active, resolution, flip, and let's also add it here. So I just added the active and flip, and I added it to here as well. So now when I go full screen, I can disable my camera and re-enable it. Yep, there I am. And I can also flip it. So now let's do it like this. Is that right? Yeah. So that's what we're doing right now, every note. If you want a major key, it's just the white keys if the bass is C. So what that is let's take the root note as 0, 0, 1, 2, 3, 4, 5, ignore 6, 7, ignore 8, 9, ignore 10, 11, and 12. If we want a diminished key, which is then, so again, that's this one, 0, ignore 1, ignore 2, 3, ignore 4, ignore 5, 6, ignore 7, ignore 8, 9, and then ignore these as well. So for every scale, if you're familiar with the scales or modes, then this should make sense. Otherwise, I'm just trying to explain what it is that I'm about to do. So let's go back into Pops. And the way I want to represent this is using a DAT. Actually, let's go back up. No, we don't need to go back up. I'll just go into F1, get rid of that, grid, diff, pixel. Yeah, let's keep this on. Go into our Pops and create a DAT, a table. And I can't remember how to use this actually. Set size. We want, I don't know, let's say 5 rows for now and 13 columns. And I'll explain why 13. Let's call this table MIDI scales. So this is how I want to format this. Here I want to write the name and then which note to use, starting from 0, because we can shift the bass notes. So this one's chromatic's easy. Chromatic's everything. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I need to add one more. Oh, actually, no, I don't need to add one more. That's it, 12. So delete that. So let's do a major. And let me actually piano keyboard. Yeah, this is good. In fact, let me do this. So major is all of these white notes. So 0, 1, 2, 3. No, so 3, 4, 5. Ignore 6, 7, 8. Ignore 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, keep the rest blank. The minor, there's actually a few different minors. I'm going to use the natural minor, which is that. And then it goes up to there as well. So this one is 0, 2, 3, 5, 7, 8, 10. Because we go up to there. So we go there, there, there. Then let's do a pentatonic minor, which is a classic blues scale, which is like this. And sometimes you put in one of these. But I'm going to ignore those for now, so just... And that is... So the pentatonic minor is 0, 3. So again, 1, 2, 3, straight up to there. 0, 3, 5, 7, 10. There's only 5 notes. 1, 2, 3, 4, 5. That's why I call it pentatonic. Let's do a diminished, which is that. Whoops, I didn't mean to do that. That. So that is 0, 3, 6, 9. So this goes in multiples of 3. And the next one, the Turkish one, it's like Hijaz Kar. It's so actually the original is not like that. It actually uses microtones. It's a microtonal thing, which obviously we can't do with Midi. Close enough. Let's add another row. Add below. Hijaz Kar. So that's 0, and then 1. So it goes up there. Then it goes. Oh damn. Then it goes all the way there. So that is 4. Then 5, 7, 8, 11. Okay. Sweet. So those are our scales. Now we want to select one from this. We want to select the row, so select. And well, I could say select by index. If I do this, bind, so I can go through 1, 2, I can select the row. But actually there's a nicer way of doing this, which is let's do by name. So I could type major, and there's the major one, there's the minor, there's the minor. But we can put this in a drop down. Go to this pop, customize, and we are going to create, let's call it a music scale, and we're going to call it a menu. And let's also open up parameters. So there's a, what was that, music scale, label 1, label 2, label 3. And that's here. write the name on the label, and you can go to the menu editor. But there's a cool way of doing this, which is menu source. And there's a Python command that automatically takes the table. This is a Touchdesigner Python command that automatically takes the table and creates this whole format that you need. And you can look that up under TDU Touchdesigner, the TDU module. There's a whole bunch of very useful functions here, and at the very bottom there's a thing called table menu. TDU dot table menu, and you give it the table and then a bunch of parameters. You give it the table operator, that table, the name column, optional column name or number for the names. The default is 0, which is good because the 0th column is already the names. The label column, default to none, which means use the names as labels. If we wanted it to use a different column for the values versus the labels, we could do that, but we don't. Include first row, the default is false, because quite often you might have a heading row. In our case, we don't have a heading row, so we're going to need to set this to true. So again, it's tdu.tableMenu, and I just need to write here tdu.tableMenu, and I need to give it a path to this. Now, if I type table Midi scales, this is not going to work. Gave an error because this script is running at the level of this menu, which is up here. And up here at this level, there is no table Midi scales. Table Midi scales exists inside this, so I need to put /. And it's still giving me an error. Oh, op. I need to say op, obviously. It's not a string, it wants the operator. There it is. So major, minor, etc. Now I just need to link it here. So let's take that, plonk that there, bind. Ta-da. So that's working nicely. Okay, so next, I want to send this into my shader. What I want to do in my shader is I want to look at the index and then use that index into this array. But there's a problem because I don't know. First, how would I send this into my shader? I can convert it to a chop. Let's actually just add a null first and call this music MIDI scale chop. And then in my shader, which I haven't written yet, but I can reference that in arrays. So, oh wait, sorry. This is a MIDI scale that, and let's convert that to a chop. No. That chop. And now let's add that to a null. Now MIDI scale chop. And in my GLSL, I can take that and call that music scale. So now this is being passed to my GLSL as an array. However, again, I don't know if there's a better way of doing this. The scale is a variable length. So when this is converted to a DAT, you can see that all of these are 0. So how am I going to know where the length actually ends? And for one thing, I can't have a uniform in GLSL. Like, I'm going to define this. Where's my here in my GLSL? Let's put that there. And the way I would define that is I say uniform float music scale, but I need to say how long it is. So let's say I do 10. It's giving an error. Why is it giving an error? Let's look at that. see it's saying redirected already declared as uniform 12 element array, not 10. So I need to put 12 there. And what I'm going to do, and again, I don't know if there's a better way of doing this. First, like define music scale length 12, and I'm just going to use that. Okay, so that number has to match the length of, let me tidy this up a bit. Let's do this. The length of this has to match this number. For now, I'm hard coding it. Maybe some of the Touchdesigner other folks can let me know if there's a automated way of getting that number. But that still doesn't solve the problem of the scales of variable length. So I can't send in, like this code, I can't make this code change based on the length. So what I'm going to do is I'm going to append how long each scale is to the end as a new column, and I'm going to read that in my code. So I'm going to know, for example, if I choose pentatonic, then the number 5, I'm going to automatically read that and pass that in. And if I say, oh, where's diminished? Oh, see, diminished is missing. So chromatic is missing. Why is chromatic missing? Pause, stop, think. It's because I need to add include, what was it? Include first row is false by default. So I need to say include first row equals true. Okay, so now if I choose chromatic, I want the number 12 to go in, etc. So I'm going to have to write another little script here. So this is going to be a script, another script that, and let's call it get count. Again, this is a script that's very similar to the previous one. We don't need the onPulse, we don't need the setup parameters, we just need this. So again, we clear. Again, I'll say input that equals script op.input 0. So we just got the input that. It's one row, so I can say row equals input that dot rows 0 and append script op.append row, that row. If I do that, okay, so what's happened is I read the row, I get the dat, I read the row, and then I append it to script op as a row, but we get all this stuff. Why? Because row internally is of type cell. Like, let me just do print row. Ignore that error. That's this only runs when the input changes, by the way. That's why nothing's being printed. So I need to, because that input isn't changing, you can see there that there's no data flowing, and so it's not triggering. So I'll just change this. Boom, it was triggered. And this is what my row is. Row is a list of cells, which is this complex type. We don't want that. So we want to get the row, if you recall. In fact, let's just go back to the Python help. That class, accessing table content, val. There's this always parameter val, which is whether to get the whole cell or just the contents. So we want to say val equals true. Okay, there we go. So we've got all of the contents of it. But we don't want it like this. We want to iterate through and find the first blank cell and count up to there. So let's redo again another loop. Count equals -1, because this is only going to run once when you change the scale, and it's never going to run again. So for I in range well, actually no, we can do for cell in row. So now this, or let's call it, just to be clear, cell val in row. If cell val equals blank, again, if we look here, those are blank, then pass, which means come out of the loop, otherwise increase count. And I'm starting with -1 because I want to ignore the first one. This doesn't count, that's the name. If I started with 0, it's gonna count that. I want to ignore that. And now let's append that to the row. We don't need that return. Oh, okay, so what I did, I said rows. Rows returns a list of rows, and even though there's one, it's still a list of a list. So when I append it, it's acting like that. I get this, which is not good, because it's returning a list of a list. You can see what's happened. The number go there, and the whole entire row went there. So that's all wrong. That needs to be row. Okay, there we go. Et voila. So now if I change, let me, yeah, the 13, so now we have a new column, 13, which shows the number of non-zero notes. Diminish this 4, just carry 7, etc. So again, the script, we clear the table, which is the current table, the outgoing table, read the input table, input that equals script op, which is this operator, the first input inputs. So we now have access to this, whatever's incoming. We read the first row, and we get it as values, not as cells. So now we have a list. We initialize count to -1 so that we ignore the first column, iterate through every item in the list. So iterate through every item in the list. As soon as we see a blank, we pass, we jump out of the loop, otherwise we increment count. And then we append the count to the row, and we add that row to the current table, and that's what we have. That goes into our null, and then that goes into our dat2, and that goes into our null chop, and you can see the last item, the 13th item, is now the count. So if I go to chromatic, that's 12, that's 7, that's 5, and we pass that into our GLSL. It's giving an error. Why is it giving an error? Because now this chop is 13 items, but in our code we said 12. 30, wait, it should be 13. Okay, so now in here, music scale has our music scale length, and now we can start mapping from the point index to a MIDI note, and basically we are going to override this. Here we were using _point_I to MIDI notes. We're going to override that. The first thing we can do, we have the ID. ID is 0, 1, 2, 3, etc. So like if we, let me just open that. This is what's coming in, and display text point index. Oh yeah, I think that's a bug, right? I should be seeing attribute, display attribute text point index. Okay, I think that's a bug. I think I should be seeing the point numbers there, but I'm not. Okay, here, I'm seeing it here. So 0, 1, 2, 3, 4, 5, 6, 7, those are the point indices. So if I increase that, yeah. I want to map this into my array. for example, let's say I pick pentatonic, 0, 3, 5, 7, 10. That I want to be 0. That one, which is 1, I want to be 3. That one, the next one, which is 0, 1, 2, 0, 1, 2, I want to be 5. That one, 0, 1, 2, 3, 0, 1, 2, 3, I want to be 7. The next one, 0, 1, 2, 3, 4, I want to be 10. The next one, 5, where do we go? That plus 12. The next one, that plus 12, then that plus 12, because 12, one octave has 12. So keep adding 12 until we reach the end again. Then we want to add 24, plus 24, plus 24, plus 24, plus 24, then plus 36. So we want to be adding 12. So what we need to do, go back to the GLSL. Yeah. First we need to find out what octave are we in. So int octave, no, lowercase, octave number. What we want to do is we want to divide the index by the length of the scale. If you remember, you know, if it's pentatonic, after 1, 2, 3, 4, 5, we skip. Whereas if it's this one, there's 7, it's after 7. If it's this one, it's after 12. So we need to know how long the scale is. Well, we already have that information. It's int scale length equals music scale, and it's the last one, which is, because there's 13 items and it's 0 index, so that's 12. So this is the last item in the array. So we want to do this. We want to divide the ID, which is the point ID, 0, 1, 2, etc. But let me just comment this out so we can see this again. This is giving an error because I said int, whereas this is coming in as float. And GLSL is super quirky about this stuff. We have to cast it to an int. I have to manually. In fact, if you look at the error, it's going to say, wait. So the error, by the way, is, just to show you again, you open that, the first one, that's the info, GLSL info, and that's the actual, the second one's the actual code. So I'm editing the code there. And this is where you see the error in here, not if you middle click. If you middle click, it just says compile failed. You need to look at this. This cannot convert from temp high float to temp IP int, high precision. So I need to manually convert this to an int, even though it is an integer. There we go, so scale length is there. And now I can do this. That's also going to give an error because they know scale length is an int, but ID is an unsigned int. I could just work as unsigned ints throughout. Okay, so now that works. But I want to be really careful because I want to make sure that I take the floor of this. Making it a floor turned it back into a float. So I need to convert it back into an unsigned int again. So what does floor do? The easiest way to explain this is go back to this table. Let's take the diminished. There's only 4 notes, 0, 3, 6, 9. And let's say we're processing 0.5. So 0, 1, 2, 3, 4, 5. That's 1 octave, and it's the second one. Let's say we're doing 6. 0, 1, 2, 3, 4, 5, 6. Coincidentally, it's also 6. But the point is, we have wrapped around 1 octave. So if we divide 6 by 4, we get 1.5. That might be rounded up to 2. We don't want it to be rounded up. We always want it to be rounded down. So let's say we were doing 7. we want it to be 0, 1, 2. So this is the point index. Point index 0, 1, 2, 3, 4, 5, 6, 7. What we want is we want to wrap around 1 octave and then add 9 to that. If we do 7 divided by 4, that's 7 divided by 4 is 1.75. Converted to an integer, it's not going to be rounded up because the compiler is written most likely to not round up but to round down, but we have to be sure. So we want to take the floor, so that 1.75 gets converted to 1. We also want the index within the scale, so let's call that scale index. And for that, we use the modulo operator, which does exactly what I was just doing. So we want to do id mod scale length. No errors there, that's great news. So the modulo does exactly this. It gives you the remainder. So if you do, we can probably type it here, 7 mod 4 is going to give us 3. It's the leftover. So that mod 5 is going to be, 4. You do the math, it's going to come out. And 2, 3, 4, 5 divided by 5 is going to give us, oh, wow. Oh yeah, of course, let's do this. Oh yeah, I picked a good number, 5. We can see that 4, it's going to be 5. If we divide by 5, it's 468.8. That means that we want 468 octaves, not 469. So we need to do floor 2, 3, 4, 4 divided by 5. In Python, it's math.floor. What? 2, 3, oh, divided by 5. Yeah, 468. So that truncates it. Okay, so now that we have that, we can say uint MIDI note equals octave number times 12 plus, now scale index is a number 0 to the number of notes in the scale. So for example, if we're doing 7, do it, and let's say we're doing diminished 0, so there's 4 notes. So let's take these. Let's say id equals 7, and let's say scale length equals 4. This is GLSL. In Python, we need to say math.floor. That's 1, so that means 1 whole octave plus. So let's say, octave number equals this. So what is octave number? 1. Then scale index. Let's check that whole thing. So what is scale index? It's 3. Remember, we're working with point number 7. It should be 0, 1, 2, 3, 4, 5, 6, 7. So now we need to use that index. Let's get rid of this actually for now. Let's call it scale note, and that is the music scale. Now we can look into the array. You need to put the semicolons, it's very brutal. Again, music scale is floats. We need to convert that to a uint. We could work in floats, it doesn't make a difference. So now scale note, scale index was 3, 0, 1, 2, 3. The scale note is reading into the array, so it's going to give us 9. And then we add them together. MIDI note octave number times 12 plus scale note. And then we can write this back to our MIDI note attribute. And we can see here how to do that. That's the syntax. So we type MIDI note ID equals, we need to convert it back to float. Actually, no, I'll keep it like this. I'll just say MIDI note. That's probably going to give an error for a number of reasons. Let's see why. MIDI note undeclared identifier. So first of all, I believe I need to say in the GLSL what I'm going to write to. And I'm going to write to MIDI note. So I need to do that. Oh, it worked. Okay, great. That was enough. Now let's look at our pop. MIDI note. There it is, 0, 3, 5, 7, 10. So here's our index, and it's mapping. It's perfect, 0, 3, 5, 7, 10. Let's change to chromatic. So that should be the same. Let's like Hijaz car, 0, 1, 4, 7, 5, 7, 8, 11, octaves over. 11, 12, 13, 16, 17, 19, 20, yep. 24, octaves over. It's working perfectly. The last thing I want to do here is I don't want the starting note to be 0. That's like way, way, way down. I don't think it's even on the piano. It's like way below the piano. So let's add a uniform. Let's call it bass note. And let's make it a unsigned int. And by default, let's make it 60. And let's customize this. Let's put that there. We don't want all that, we just want 1. We want an integer of size 1. Let's, instead of value, let's call it bass note. And from 0 to 127, default, let's make it 36, which is a C, a couple of octaves below. Loads of errors because it's looking for that, and that doesn't exist. What we have is that. So let's reset all of those and then copy the bass note onto there and bind that. So now we're sending 60 bass note unsigned int. Let's go back to that, add a new uniform. Uniform unsigned int bass note. So I'm not going to go deep into shaders. I'm kind of, you know, that's a whole big thing, but just to give a overview, uniforms. So here the way, I think it's a little bit confusing. These are all uniforms, and they're uniforms of different types. Uniforms are values that you send into a shader that is the same across everything, all of the, whatever it is you're running the shader on. If you're running a pixel shader on a top or a fragment shader, so here this is a fragment shader or a pixel shader, this code is going to run for every single pixel, and the uniforms are the same. You're sending data in from outside, and it's going to be the same value for all pixels. Attributes, however, vary per thing. And in the case of here, in pop GLSLs, which are compute shaders, every point has different attributes, as you've seen. We can see this as a table, so each row here is a point. Each point has its own MIDI note, its own MIDI on, its own MIDI trigger, its own MIDI vel, and has all of these attributes. But the uniform is a temporary value that only exists for the duration of this code. And this code, see, there's no loops here. The loop is happening behind the scenes, and this code is being run automatically in parallel for every single point. Usually we use shaders for performance reasons. When you have millions of polygons, millions of vertices, it's very advantageous to run them all in parallel, because that's what GPUs do. In this case, I've only got 20. I'm not doing this for performance reasons. I'm doing this just for ease, because actually I find it a lot easier to do it this way than to do it in Python, because if I were to do it in Python, I would have to keep track of all of these attributes. I'd need to create loads of arrays, an array for each, or I could have to create an object type and create my own object type and then create an array of that object type. But I'm getting it all for free here. So I'm getting no performance gain. If anything, reading it back, this might even be a bit of a performance hit, but it's so small that it's completely negligible. I'm doing this for ease of use. So anyway, uniform, I digress. I have this bass note uniform, which is 60, and I can change that. Let's make it, 36. I can read that here, bass note, so I'm gonna just add bass notes. And now let's have a look at my Pop 2. MIDI notes, see, they all start at 36. And if I change this, have a look here at my MIDI notes, I can change the bass note. I could make this a drop down, C, D, E, all that kind of stuff, but I'll leave that for now. Change my scale, and that's all working. And now let's put the music back on. So one thing that's interesting, diminished only has 4 notes. So, look, it's going from 24 all the way up to 93, which is a very high note. See here, that's a very high note. And this one is 24. Where is it? Wait, my camera's flipped. Let me... okay. So that's very deep. If I go to chromatic, it only goes from 24 to 47. So I might want to go a little bit higher. Okay, that's working nicely. There is one additional complication. Let's say this is 8 by 3 and it's going from 36 to 76. Let's say I make this 10 by 10. I'm going to mute it. It's going from 36 all the way up to 205. That doesn't even exist. MIDI goes up to 127. And even like 127 is insanely high. Like you don't want to go to the 127s. So what I want to do is I want to wrap around. I want to add a new property, which is like octave. So maximum number of octaves. Let's make it an int. And let's make it somewhere between 1 and, like a piano is what, 8 octaves? 10? I don't actually know. Let's say 8. So, and what I want to do is I want to wrap this around. So that's there. Let's go back in here. My GLSL, let's add a new thing and let's call that a new uniform, vectors. And again, it's a bit confusing because this isn't a vector. This is just a single number, but you can choose, it's going in as a vector, but as a one-dimensional vector. That's how it's been implemented here. So again, let's choose unsigned int, and let's put the octaves binds that. So now we're sending that number in. Let's go back to our code. Uniform unsigned int octaves. So you would think that all we have to do, so this octave number is going up and up and up. And for example, let's go back to our Pop 2. We have 100 points. And so this is index 99. If we do the maths, scale length, let's say we're working with diminished. So we'll say, let's clear that. Scale length is 4. We're working with diminished. And let's say our ID is 99. What is the octave number? Octave number. What is it? Octave number. It's 24. That's insane. We don't want to go 24. We want to wrap it around. So if my max octaves is, let's say, 5, we can do octave number equals octave number mod number of octaves, 5, maximum 5, so 5. So what is octave number now? It's 4. That's good. So it's going to go up, 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 up until we reach 5 octaves, and it's going to go back to the beginning. So all we need to do is here octave number equals octave number mod octaves. And now let's have a look at that. So we're going from 36. In fact, let's make it 0 so it makes the math easier to check. And we make it, let's say, 3 octaves, the limit. So it's going up, 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 all the way to 35. And then it goes back down to 0. So this is working. This table is correct. If you make that 5, 5 times 12 is 60, so we should never go above 60. Yep. Even if I change scales, let's choose the diminished. It's going to reach it a lot quicker this time because there's fewer notes. So that's good. And if I change the bass note, let's make that 24. Okay, so it's still 5 octaves above that. So 24 plus 60 is 80 something. Yeah, 84, so it's never going above 84. So now we have the right table. However, if only it was that simple. The table is correct. Let's put the Midi on. So something weird is happening, and there's some super high notes. There shouldn't be. Let's make the bass note 0. I'm still hearing super high notes, and if we look at this, there's nothing above 33, which is super low. Why? And it's also sounding, it's not sounding like the scale. In fact, let me do this. Let me make that 0. It's going to be a divide by 0 now. So in my code, I want to say if octave number is greater than 0, then do this. So that way we don't get a divide by 0, because if we don't do that, look, you see the Midi note? There's a divide by 0 happening because octave number is 0. Octaves is 0, sorry. So if octave number is greater than 0, no, so not octave number, sorry, if octaves. Octave number is how many octaves have we wrapped around this scale index is which index in the scale are we? What note in the scale are we? And then final Midi notes. Wrap around. Also, as a naming convention, people usually do this. I'm gonna get loads of errors now. Octaves. It does make the code easier to read, actually. I'll do that. So there should be loads of errors. I don't know why I didn't get the errors. So these should have U and that should have a U. Okay, so let's get back to this problem. It took me a while to figure out why the hell this was happening. Again, let's say octaves is 3. The numbers are correct. 0, 3, 6, 9, 12, 15, 0, 3. This table is correct. I'm going to mute this for a second. But let's see what's happening here. This craziness. And to make it easier to read, I'm going to reduce the number of cells. So let's say the octaves is, max octaves is 2. It should never be above 24, 0 to 24. And I'm going to reduce the cells to, let's say, 6 by 5. So there's 30 notes. Okay, I can reduce a lot less because we're using diminished. So there's 4 notes in an octave, and we reach an octave in just 4 notes. So even if I do, you know, 4 by 2, so let's do 4 by 4. That should be 2 octaves. Sorry, we go 2 octaves and 2 wraparounds. Let's put the music on. Let's increase the bass notes. I can hear that this isn't diminished. Okay, let's go back to 0 so we can see what's going on. These should be what's being output. We should have only 1, 2, 3, 4, 5, 6, 7, 8 notes. But what's happening is, look what's being output. N0, N3, N6, N9, N12, N15, N18, N21. That's good. But then N22, N23, N24, N25, N26, it's going back to chromatic. So if I make this 10 by 10, what it's doing is the first 2 octaves is correct, and then it's just all incremental. It took me a while to figure this out. The reason is because, let's go back to this script, dat to Midi chop. And let's just put here print row. This is outputting correctly the script. 0, 3, 6, 9, 12, 15, 18, 21, 0, 3, 6, 9, 12. This is outputting correctly, but it's outputting the same channel name multiple times because it's wrapping around. And a chop here, the table can have it. This table is correct. 0, 3. So this is correct. When this is converted to the chop, this chop is not correct because a chop can't have the same name multiple times, and it's not overriding the previous one. It's just adding it as a new channel, but because that name exists, well, here it is, make duplicate names, make unique. So I could say keep first. So now it's keeping the first entry. But we don't want to do this because if I move my hand here on the left, and it triggers that note, but then I move it up here, but that note is being processed afterwards, it's going to ignore that and it's going to use this. I don't want to do keep last because then the opposite is going to happen. If this note and this note up here is the same note, which one should it use? Should it use this one or this one? So you can see right now, nothing's being updated. Now it is because it's using the last one, and this bit up here is recent. Replace first with last. I could do most recent changed. It's also not going to work because I'm updating everything on the same frame. So if I do here, it's not going to work. So basically what I ended up doing is I said make unique. So which one should I use? And my heuristic is we should use the one that is the highest, the maximum. And that's not an option here. If it was, we could do that, but it's not. So we need to go back to this code. That code is this one. Here we were doing a very simple naive go through, read and add to the table. Let me go back actually and make this a little bit less again. Let's make it 4 by 4 so it's easier to parse. And let's do this. Yeah. So this is going up to 23, 24, 25, 26, 27, 28, 29. We don't want any of that. So here's what we need to do. We need to iterate through all of the rows, but instead of adding it to the table straight away, instead of having a table like this, we need a table that only has 0 to 21, doesn't have these, and it uses the maximum value. So what that means is if I'm triggering here, and I'm triggering here, and it's the same note, and I stop triggering here, but this one is still triggering, or it's a bigger movement, I want this one to come through. But if this one is a bigger movement, I want this one to come through, because we ultimately, if we're limiting the number of octaves, we're going to have the same notes mapped to different places. So how do we do that? We don't write to the table straight away, so let's get rid of these two lines. We're going to create a dictionary, an object, and it'll be clear what that is in a minute. So all of this stays the same. I'm going to do, let's do this actually. Let's do retdict Midi string equals a Midi vel, and then let's print. Ret is short for return, and dict is short for dictionary. What is a dictionary? Okay, it's giving me an error. What's the error? Midi vel is not defined. Yes, I meant that one. Too many different things. So this is what it looks like, what an object, what a dict looks like. In fact, let me also do this. No, it's this one. Just so it's easier. When you see this line, that's when the loop is starting. So the loop starts there. And at the beginning, retdict is nothing, it's empty. Then N0 is that. Then it's this. So N0 is still that, N3 is that. Then it adds N6, then it adds N9, then it adds N12, 15, 18. So at every iteration, this dict is growing. And then it keeps overwriting. So it keeps adding. So then if it comes back to N0, it just overwrites the older N0. So instead, what we want to do is we don't want to write that there. We want to say if the Midi string already exists in retdict, if retdict already has this note that we want to write for that particular channel, then we want to say retdict equals, take the bigger one between Midi vel and retdict Midi string. So if we already have this Midi string is one of these, if for example ch1n0 is already in retdict, then take the bigger one. Otherwise, just write it directly, else, oh, there should be a colon there, retdict Midi string equals Midi vel. And why is that not working? This is not support item assignment. What? Oh, by the way, this is Python. In Python, this is a comment, and in GLSL, because it's basically a C-type language, it's that. So that works. Oh, okay. So here's my mistake. I said retdict equals that. So here I'm defining, this is why languages that are not typed are problematic. I created reddict as an object, as a dictionary, but here I overwrote it and I'm writing the whole value straight to that, whereas this should have been MIDI string. Okay. And I could be fancy. I could write this whole thing as reddict MIDI string equals that if this is like a Python syntax, else. That also works, but I think that's a bit harder to read, so I'm going to leave that but comment it out. Okay, let's now print reddict. So now it looks the same, but it's using the biggest one. For every value of this, it's using the biggest one. And now, let's, instead of printing it, let's add it. So afterwards, not before we were writing each row by row to the table in the loop, now we want to come outside the loop. In Python, indent matters a lot, whereas in C-type languages, indentation doesn't matter. We use brackets to denote blocks. But here indentation matters in Python, so let's write script op dot append rows this time. Note, not one row, but all of the rows. And reddict. Now this expects a list, but we don't have a list, we have a dictionary, which is key value pairs. But we can convert it to a list using items. So this converts it, actually it converts it to something known as an iterator, which isn't going to work, and then bummer. Okay, I hope you didn't do what I did, because it crashed. So let's try that again. Yeah, I had to go back to a previous version. Where are we? Oh yeah, so we have ret. Is this the right version? Let's see. Yes, so we are writing the maximum into this dict. We're iterating row by row. We're iterating row by row, and we're writing it into a dictionary. Only if the MIDI vel is bigger, if it exists, we check and get the bigger value, otherwise we write it straight away. This is a dictionary, and if I print the items, it looks like this. It's a dict item type, and I tried writing that to the table and it crashed because it's not a list. We have to convert that to a list. So now we have a list. In fact, we have a list of lists. So in fact, instead of writing it, updating it let's just take it out one so it's outside the loop. So now we have this. Again, if I don't this is what reddict is. It's a dictionary, which is not a list. You access it by using these channel names, not channel names, keys, they're called keys. We want to convert that, get the items, which is a dict item, and convert that to a list. And now this is the format, it's a list of lists. See, the first item is that, which is a list, which is name, value, name, value, name, value, and it's a list of name values. Okay, now we don't need that as well. Now we can do input that, append rows, and then this whole thing. In fact, just to make sure I don't make an error, let's do ret list equals that, print ret list. Yep. Now let's do script op dot append append rows ret list. Hallelujah. This table is big. Let's, make it again 10 by 10, and it's wrapping around every 2 octaves. But this is only 1 row per note, and it's using the largest MIDI value. So if here it's going quiet, here I'm re-triggering it. And then that's going to the DAT. Let's enable the MIDI. And let's set the bass note to 60. That sounds good to me. 2 octaves is a bit boring. Let's make it 5. But again, if we weren't doing this, it's still going up to these crazy places. So we still need it. And then very quickly, let's go back to our container, see what it looks like. It looks like that. This is the container 1. Let's go to customize. Let's create a header called Midi. And put it about above layers. There it is, make it a section. And let's see, we don't take the scale. Bind that, bass note. We could call this the root note as well, the octaves. And is there anything else that we're missing? Let's see. We've got those, that, yeah. Oh yeah, let's put these. So this is in diff. Let's call that prep. We don't need to touch these, I don't think, but let's just put them there anyway. Oh yeah, we should put, oh no, we'll leave those. Thresh, trigger. I believe that's it. Oh, I had, oh yeah, let's also add Midi. Let's add this. So in the version that I showed, I had created maps so that I could have different MIDI channels. I could have different instruments, where I had piano on one side and the synth on the other side. I think this video's gone on way too long, and I will show that in another video, in the next video. So I'll show the map and then